Hi, this is Craig, and I want to talk to you today about stacking your Seestar Mosaics in Astro Pixel Processor, which I'm going to refer to as app, which is kind of confusing, but that's what it's called. I am no expert using this app called app, but a friend of mine was having some trouble stacking his Seestar Mosaic, and we thought that one way for me to show him what I might do is to make a video and use his data and show him how I stacked it with app. So that's what this is. I've just recorded this new intro and outro, and the rest is going to be his data. One thing I'll tell you is that because the registration process in app can take some time, and for this particular data set on my machine, it ran about 3 hours. I ran the registration process the night before recording the video, and then we work with the registered frames in this video. So you'll see me refer to the data I sent you last night, or the registration that I ran last night, and that's what I'm talking about, is having done that. But when you do it, you will just go right to the registration step, and then it'll take as long as it takes for you. And we'll fast forward through the stuff that takes a little bit of time. So let's get to it, stacking Seestar Mosaics with app. It is Astro Pixel Processor. This screen ought to look somewhat familiar to you. We've got our tools, the tabs for our tools over here on the left. Each tab has some options listed underneath of it. And then in the center, this is going to show like what's going on in the left panel, like a log. And then in the right panel is the image viewer. Over here on the far right is a panel that I rarely refer to. About the only thing I do over here is when I get all done, I might choose from this drop down. This does kind of an auto stretch to show you what your final image looks like. And I might mess around with that, but I never save that data. It's just a way to see what you've got. So we're going to start by choosing a working directory, and that's this top button over on the left side. And this is going to be where all the output goes. And so I have your data organized into, I have the registered frames from last night. Here's our stacked folder where we're going to put our results. I've also got a folder with all of your lights in it, so that's labeled subs. And then my test stack, I sent you the results of that last night. So our output we're going to put in the stacked folder, so we'll choose that and open, and then that shows up in this top button. The tabs, we just do them in numerical order, kind of. They will get executed in numerical order whether we manually do that or not. So this 0, I never change anything here, so it ought to be okay as is. On the load tab, what you would normally do is load all of your subframes by pressing the light button and then load your subframes. Since I've already got registered frames, I'm going to load those. And the option to select all doesn't work here, so you have to drag through all of them. And we have 541 frames. Now it will automatically fill out the object name. I had it filled out from before. I like to take the space out, and then I like to put in how many frames this is, because when I come back and look at the integration later, it's nice to know what did I do, how did I get this. For Seestar data, that's all you need to do. Because the calibration frames are built into the individual subframes. Otherwise, you might load a master flat, darks, biases, and pixel map. You would do all that here. But for Seestar data, we just load in our lights. If you had calibration frames, you would go to the calibration tab and do that. It will try to do that and realize there's no calibration data, and so it'll just move on. Then step 3 is analyzing stars. Now, what I normally do at this point, once I get my lights loaded, I actually go right to register and do, it'll actually do analyze, it'll actually do calibrate, analyze, and then register. And then at register, you can stop and decide, do I want to use all these frames? But we already have registered frames, but since I did that last night, we don't have the output. So I'm going to run the analyze process again, and this will take a minute. And so I'll cut here and jump back in when it's done. Okay, this looks better. We've got our analytical results back. They're all over the map, and so they can be hard to figure out. But what we do is go down here to our list of files and then click on the column heading that we want to sort on. So for example, here's stars and star density, number of stars that is. If I click on that, then I get it sorted by number of stars. So on the left is the frame with the most stars. I'm going to click on that and then choose registered, and let's look at that frame. By the way, because we're looking at a registered frame, it's going to show up located on this panel where it would be located if the rest of the image were there. So this has a lot of stars. Whoops, accidentally zoomed out there. This has a lot of stars compared to the other frames, but it might just be because that's where this particular panel of the mosaic is. It's in an area with a lot of stars. We come down here to the very last one. There's the last one. We'll load the registered one of those. And this one says it has the fewest stars. So most of the time, this isn't necessarily a good measure, but you could imagine like if the roof had closed, you would have 0 stars, and so this would be a way of saying, okay, obviously I don't want to keep that one. But in your case, all of that looks good. So we can go to another column here. This is, what is it, full width, half minimum. Never completely understood this. If we look at the worst one here, load the registered frame. And I'm not sure what that's telling us. That looks like a reasonably good frame except for a chunk of a airplane or a satellite here. Quality score is like an overall look at all of these parameters. And what you tend to see is that all of the other measures kind of move in the direction of the quality score till you get down here to the end, and the worst frame probably has the worst of these other parameters as well. So let's load up the last one of those. And for overall quality, it says that's your worst one. And it's a little bit light. It doesn't have a whole lot of stars. Got a little bit of a satellite trail here, but frankly, I don't see anything in that frame that really scares me. I would probably go ahead and use that. And that's one of the things that I do to figure out if I want to omit anything, is I look for the bends in the quality curve. And when you come down here, it's like on a steady decline, but then somewhere around in here, it starts to really drop off. And so I might spend some time looking at these bottom ones, and especially right here, the last 2 or 3, it really drops off. And I might spend time looking at those to see if I want to include them or not. But out of 541 frames, you might have 3 that the quality score comes out bad. That's not a whole lot. They're going to get overwritten by other data anyway. Star shape is an interesting one. My understanding of it is that it's a measure of height to width. And so you want your stars to be round, and so it ought to be 1-to-1. I don't know that I've ever seen a Seestar produce perfectly round stars. We scroll up on this list. What you see, we have 1.16, which is longer in one direction than the other, and then we do drop through a few of them that are round. And then most of them are not round. But this is normal. This, in fact, I know I said I don't normally see any, but that's not true. This looks more like what I remember seeing for Seestar, is a little group at the top that look pretty good. If we come down here to 0.84, that would be 0.16. It was 1.16 on the high end. 0.84 would be the other direction. And we're on 198, so that's less than half still. But let's look at this 0.84. Load it. We'll look at the registered. And I'm going to guess that it looks perfectly fine. And I might be a little wrong. Yeah, those don't look terrible. We don't have a lot of a resolution here, but, this guy, I don't know. Those don't look too bad to me. Let's go down to a really horrible one. All the way at the bottom, we have a 0.24. Load that guy. Okay, so now we've got, whoops, I zoomed out. That's very obviously elongated to me. And I would consider dropping this guy out. And he's at 0.24. So let's go up to, say, 0.34 and see what that looks like. Load, registered. You can see they're still elongated, but they're a little shorter. 0.44. Load, registered. And we'll move over there. Again, these are just a little bit elongated. But they're starting to get to where they're not horrible. Let's look at a 0.5. What are we doing here? There we go. So 0.5 would be twice as wide as it is tall. And from a distance, those don't look entirely horrible. But, when you really study them, you can tell that they're wider than they are tall. The problem is we don't want to delete too many of these. 0.6, load frame, registered. Those don't look a whole lot different. And the thing with the 20-second exposure, and you can see some star movement, my assumption is what that also means is that my nebula is moving too. So it's not just the stars that are out of shape, but the nebula is moving. So you may or may not want to include some of these down on the end. Look at 0.7. Where'd it go? There it is. See, these are looking, they're slightly elongated, but they're not looking horrible. And we're about halfway through our data. So you can see over here where it says view, and there's a black line that runs right up through the word view. That's where we are in your data. And you're pretty much right at halfway. So just for the sake of doing it, I'm going to come down here to our I'm just going to drop everything that is 0.5 and below. Okay, so I highlighted the first 0.5. I'm going to go down to the end. I'm going to shift click to select. Then I'm going to right click and choose deselect. When I do that, the select checkbox gets cleared. These guys all gray out, and now those are not going to be included in our integration. All right, and you can see if we scroll this list, these guys are still checked. They're going to be included. You have the option of when you right click here, you can remove them instead of just deselecting them. That's fine. It just removes them from app, and they won't be included in the integration. But you can also delete them, and when you do that, it's going to delete them from from the folder that they're in. And so if they're horrible, I just delete them so that I don't run into them the next time I want to use these frames. But for now, we're just going to deselect so they don't get included. That's the results of analysis. Was there anything else we did? Star shape? No, there's nothing else that matters. All right, and we eliminated some, so we should get better results. Normally, this analysis step would happen when we do register, but we've already registered this data. So I'm going to disable registration so it won't try to do that. And then I'm going to skip right over normalize and go to integrate. Now the normalize step will get done when we do integrate, but we don't care about it. So we're going to let it do it, and then we're going to go ahead and integrate. On the integration options, these are all defaults: integrate per channel, integrate all lights to stack, 100%. Now it's 100% of the 412 that are remaining, not 100% of the 541. So it's going to stack all of those. For integrate, we're going to do automatic. And what else are we going to do? None of this changes as far as I know. I never change it. Okay. Multi-band blending is what handles the overlap of your frames in mosaics. And normally, if you're shooting on a big telescope, your mosaics are done in panels, and the panels will overlap by just a little bit, and like 10, 20, 30%. 30 would be a lot. And so you would set this slider for a normal, like a 6-panel mosaic with 20% overlap. You might set this around 20%, and that ought to be good enough. And that just tells it that it needs to look, where does it need to blend? How far outside does it need to look to do the blending? It's okay to do a little bit more. I think it just takes some time. Seestar data is hugely overlapped. There's much overlap between all the images, and so I would just run it up to 50%, and that's the best it can do, and that'll blend all of your mosaic frames together. So enable MBB, set it at 50% for Seestar data to get your mosaics all blended together nicely. We don't do anything with these other things. We come down here, and if you want to drizzle and pick up some resolution, you can do that here. Set your droplet size a little small. I tend to use 0.8, and then set the scale to something greater than 1. Some people drizzle at 1 and claim that it improves the data. If you do anything more than 1, you get additional resolution. I'm not going to do either one of these because we're just going to integrate what you've got. But this is where you would do drizzling to pick up resolution. I think drizzling 2:1 with Seestar data ought to work fine. But I would only do it on star clusters and galaxies where I want my stars to be really nice and tight. For nebula, I don't know that I'd be as concerned about it. When you drizzle, you introduce noise, and so you have to deal with that in processing. Okay, so before we integrate, I'm going to change this to 412 because we're now down to 412 frames, and we are ready to integrate. It's going to use our default directory up here, the M42 stacked directory, so we don't need to set the save directory. And I'm going to punch integrate. This is going to take a little while, and I'll cut out here and pick it up when it's done. Okay, so it is done integrating. Some things I'll point out. Let's see, we lost that. Back when it was integrating, it told us that the total number of pixels in the output was 11,983,137. And if you divide by the size of your 1x Seestar 1080 by 1920, it works out to be about 5.66 mosaic. So it's 5.66 times. So normally if you did a 2x mosaic, you get 4x the area. You've got 5.66. But if you look at this, you see that, along the edges, there's very little time on there. And so you have a lot of noise, especially on this right edge. A little bit on the left edge. You can tell the top isn't as dark. And then this is with 30% background. This is the kind of the brightest stretch, auto stretch that app will do. If we come down here to one of the 15s, it stretches it a little differently. We kind of lost the dark stuff here. We don't really care, but what we're seeing here is that background doesn't look as bad as I thought it looked in the Seestar's output. We pick a 20% in the middle. You do get a little bit of this lighter colored stuff, but I think when Seestar denoises, it's blending all of this noise together and make it look lighter. And as a result, it looked a little blotchy to me when I first looked at it. Okay, but you're going to crop this down to something that's a little bit more like 2160 by 3840, which would be an actual 2x mosaic. And if we zoom in, we can see that, our stars are a little bit stretched out, but they're not absolutely horrible. We've got some detail in this dark stuff that's in the middle. A lot of people miss that. So that's all we do in app. Now app this thing we're looking at on the right, if we go back out to our folders, we put our results in stacked. And so this is the stacked fit file, M42 412 by 20. That's the result, which is what we're looking at here in app. The stretches that we're doing do not apply to the file. That's just for us to look at. If we want to save those, like I sent you a saved one last night, you can hit the save button and it'll let you just save whatever the current image viewer looks like. But it's not normally something that I would take that and process it. This is going to go into Serial and do your normal things there. When we did the integration, we got a few more parameters. If we care about those, we can look at them. Let me scroll up. Oh, and I forgot to notice how long it took. Maybe 5 minutes. I forgot to notice that when it finished. I wrote down when it started. Star shape, registration. Okay, yeah, we picked up sky background, dispersion, signal to noise ratio. For signal to noise ratio, it gives 3 numbers, and I don't know and understand what they are. I sent an email to their support address, never heard back. But if we sort by signal to noise ratio, that's the purple. And the instructive thing is to look at this worst one. So this frame apparently has the worst signal to noise ratio. Looks like a frame to me. And this one has the best signal to noise ratio right there. So it's hard to say whether you might go back and remove these and reintegrate and see if that makes any difference as far as getting rid of some noise. I wouldn't. I think I like your result. Okay, so that is what we did to stack the Orion Nebula using Astro Pixel Processor. Hopefully this has been helpful to you. Let me know in the comments or however you have of getting a hold of me if you have any questions, and I'll do my best. Like I said, I'm not an expert with this app or with anything related to astrophotography, but I'm happy to help when I can. Thanks.